In this video, we will discuss the problem rotate matrix by 90° in the anti-clockwise direction. The problem has been previously asked in companies like Microsoft. So let's see the problem statement here. Problem says that we'll be given a matrix here and we have to rotate this given matrix by 90° in the anti-clockwise direction here. So let's see what we have to do. If you will see, let's say we were given the matrix that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you will rotate this matrix by 90° anti-clockwise, so this particular top row that is there, it will rotate by 90° and it will look like this. So 3, 2, 1 will come here. Now after that, like you had 4, 5, 6, so it will come here, and then 7, 8, 9, so it will come here. So this is the expected output after rotating the matrix by 90°. Now how can we solve this particular question here? So one thing that you can observe very carefully is that all the elements that were there in the 0th row, okay, all the elements that were there in the 0th row, after rotation they are in which particular place? So they are in the 0th column here. All the elements that were in the 0th row, they are now in the 0th column, and all the elements which were in the first row, now they are in which column? Those elements are in the index 1 column here, so they are in the first column. All the elements that were there in the second column, index 2 column, all the elements that were there in the index 2 row, they are in the index 2 column here. So one thing that I'm very sure is that if an element was at mat of ij, let's say an element was present at I comma j index, now in the updated matrix, what will be the column for that what will be the column for that element? So if I was the row, if an element was at the 0th row, now it will be at the 0th column here. So if it was at the ith row, it will be at ith column. So in terms of column, I can write I here. Now after this, we have to identify that what else happens. So if you see after this, if an element was let's say if an element was in this particular place, let's say if 6 was there, right? Now if 6 was there, suppose the element 6 was there, now it is occurring where? It is occurring at this particular place here, correct? So how can I identify in terms of row that what is the new row for the element? So let's start from the very last element here. If you will see, let's say if we have got this element that is let's say 9 here. Now what is the index, what is the value of the column here? The column here is basically equal to nothing but 2 here, correct? And remember one thing, that the n value is 3. So the column basically here, that is the j value, is basically what? The j value is equal to 2 here. It is the second column, right? Now this element goes where? This element goes in this particular place, okay? So all the elements that are there in the second column, understand one thing, that in terms of column, all the elements that were there in the second column, all the elements that were in the second column, now they are going to which place? They're going to the 0th column here. Okay, so what can I say here? I can say that the element at the jth column, it will go to which place? Element at the jth column, it will go to n minus 1 minus jth row. Okay, now what do I mean by this? If the j value was 2 here, if the j value was 2 here, so what will be the new row that it will go to? So the row that it will go to is basically n minus 1 minus 2. So 3 minus 1 minus 2. So this will give me what? 0. So that is why I need to write what? I need to write that this element will go to the new row and the new row will be n minus 1 minus j here. So this is how you can identify this very easily, that the elements which were in the ith row, now they will go to the ith column. In terms of column, the column will be I, and in terms of the new row, the row will be equal to n minus 1 minus j here. So this is the observation that you can have. So what you can basically do is you can create a new matrix, and what you can do in that new matrix is, let's say you create a resultant matrix or something, and then you can say that at the index n minus 1 minus j I, you can update the mat of ij element. Like this you can update for all the values of I comma j index in the matrix here. Now if you will see, what will happen is, firstly we can take the size of this square matrix, then after that initially we update the resultant as 0, then after that we iterate, and at the n minus j minus 1th row and the ith column, we update the mat of ij element. After that, we once we have stored this in the new list, in the new resultant matrix, then after this we want to store this resultant matrix in the original matrix, so we'll update this accordingly. Now what will be the time complexity for this code? The time complexity for such a code will be basically order of n, because we order of n square, because we are iterating throughout all the matrix elements, and the space complexity will be order of n square as well, because we are using extra space and we are declaring a resultant matrix which is going to store the anti-clockwise representation, and then we copy the anti-clockwise representation stored in the resultant to the original matrix, because at the end of the day we will check the original matrix here. Okay, now how can we do it more optimally? So what we can do is we can try and observe one more thing here. If you will see, the better approach is that we can rotate the given matrix in form of cycles. Now what do I mean by this? If you will see here, what we can understand is that there are two cycles that exist. If the n value is 4 here, so the grid is of 4 cross 4 size. So you can see that the very first cycle will be the first row, last row, first column, and second column. This will come in the very first cycle. And in the second cycle, which elements will be there? The second row, second column, second row, second last row, and second column, and second last column. So basically the internal elements. You can see that firstly the outer circle that is there, those elements will be considered in the first cycle. In the next cycle, the inner circle elements will be considered, that I have drawn with blue color. Now, how does this help us? So notice one thing, that what we can do here is, once you have identified that you can basically switch the cycles, once you have identified that you can swap in terms of cycles, then it becomes very easy. The reason being, because if you will see, initially we'll be at the very first cycle. Okay, now there are two cycles in this problem, because n value is given as 4, so n by 2 is the number of cycles that you can have. So you will have two cycles for this particular test case here. Now what will happen in this particular test case is, if you see, so we will be initially will be swapping which and which elements. So initially you can see that the corresponding elements that we need to take is 1, then we need to take 4, then we need to take 13, and then we need to take 16. So initially my I, j is 0, and correspondingly we are taking the elements at j comma n minus 1 minus I. Then we are taking the element at n minus 1 minus j comma I, and then we are taking the elements at n minus 1 minus j comma n minus 1 comma I. So we are taking the elements at the four boundaries, and we'll basically swap them. So what will happen is, after swapping, like 1 will go down, then after this what will happen, 4 will come here, then 16 will go up, and then 13 will go on the right side. So basically the elements will get swapped by one place each. So that is how what will happen is, 4 will come here, 16 will come here, 1 will come here, and 13 will come here. Once this happens, then you will do it for the next element. So the next element that you will do it for is 5. Corresponding to 5 you need 14, and then you need what? You need 12, and then you need 3 here. So again swapping will be done. So 5 will go down, 14 will go towards the right side, 12 will go up, and 3 will go towards the downward left side. So basically the swapping will be done, and these elements will also get placed at their positions. Now after that, the next element that you will be at is basically 9. Now with respect to 9, whatever corresponding elements are there in the other rows and columns, you will basically get them, and you will swap by one time. Okay, now after this what happens, your first circle is ready, and you can notice that we did not go till the like we were iterating and we did not go till the last. We only went till this particular point. So you can understand one thing, that how many cycles are we iterating for? We are iterating from 0 till less than n by 2, because total we have to iterate for n by 2 cycles. That is why we are doing this. Now even in this case, if you see, when we were iterating for the very first cycle, we iterated till which particular index? We iterated till the j index of 2, because we were swapping till 2, and then after that when it comes to 1 again, then you will not swap again for the last place here, that is this place. Okay, so you can see that my j is starting from where? My j will start from 0 obviously, but it will go till n minus 1 minus I here. The reason being, because if suppose that the n value is 4 here, so 4 minus 1 minus 0, so in like j will be less than 3 here. So less than 3 means j will go till 2. So initially it had to go till 2. So that is why that is what we have done. So j will be less than n minus 1 minus I for a particular value of I here. Now after this what will happen is, in the next cycle the internal elements will get swapped accordingly, and then the rotated matrix will be found. Now if you see, so the complexity of this code is how much? This is basically taking order of n square approach, because like first loop is roughly iterating till n by 2 times, second is iterating almost order of n times. So this is order of n square in the worst case. Now if you see, what we can do is, we can basically take the size of the matrix here. Then after this we can basically say that we'll iterate for n by 2 cycles overall, and then we can basically iterate for the first outer cycle, then the next inner cycle, then next inner cycle, one by one, and we will have we'll have to swap 4 elements at a time by one place each. So like initially we'll store the element at ij, then after that j comma n minus 1 comma I, then after that n minus 1 minus I comma n minus 1 minus j, and then after that n minus 1 minus j comma I. So basically all these four elements that you need to take at one point of time. Like you can see that I've highlighted this in the first example, which is I comma j, which is j comma n minus 1 comma I, and like this I have updated all the elements here. Now once this is done, then your rotated matrix would be found. So what is the time complexity for this particular approach? It is basically order of n square. If you see the space complexity, it is going to be order of 1 because I'm not taking any extra space. So it is a little optimal. It is a little optimal in terms of space. But is this the best code that we can write? No. We can do it more easily using the basic approach of reversing every row and then transposing the matrix. So what you can do is you can basically do it in the same matrix, but you can have some observations here. Now notice one thing, that what I can do is if I reverse each row, firstly I'll reverse every row. What will happen in because of that? So when I'll reverse every row, then the matrix that I'll generate is 3, 2, 1. Okay, then after that we'll have 6, 5, and 4. Then we'll have what? We'll have 9, 8, and 7. So firstly what I've done is I have reversed each row. Okay, I have reversed each row. Now there's one thing that is known as transpose. Now in transpose, what happens? The first row becomes the first column, and the second row becomes the second column. Third row becomes the third column. So what will happen when I'll do the transpose of this particular matrix that I've obtained so far? So like first row will become the first column, so you will have 3, 2, 1 here. Then second row will become the second column, so you will have 6, 5, 4 here. Okay, and then third row will become the third column, so you will have 9, and then 8, and then 7 here. So this is what you are going to have. So when you will do what? When you will basically transpose this matrix, then you will get the final result that was expected. So the basic approach, like the very basic fundamental observation is that you can first of all reverse every row and then reverse each row and then transpose the transpose the updated matrix here. So how can we do this? If you will see the code, so what we need to do is we need to basically first of all take the length of the matrix. Then after that we need to reverse every row. Once you have reversed, then we will do the transpose. In transpose, what happens is the ith element becomes the, like I comma jth element becomes the j comma I element. So that is why we are swapping like this. Now what is the time complexity for such a code? The time complexity taken will be order of n square, because we'll be iterating throughout the matrix elements here for reversing, and then we will be iterating for transposing as well. And the space complexity will be how much? It will be order of 1, because I'm not taking any extra space here. I'm just doing the rotation in the same matrix here. I hope you have understood this so far. Let's try and submit this code as well. So let us try and submit this code. Hopefully it should get accepted here. So you can clearly see that my code was able to pass all the test cases. Thank you for watching this video, and keep coding, guys.